Thank you very much. Our next speaker is Senzo Mghabi, and his talk is about kinetics of lime dissolution and neutralization of acid mine drainage.
So while Rahul is checking my slides, would like to take this opportunity and thank Prof. Jenny. You killed my vibe. I'll continue anyway. I would thank Prof. Jenny for laying a very good foundation on acid mine drainage, which is affectionately known as AMD or ARD. I'm not sure if I have to say it affectionately known as that because this is a threat. I'm not going to say anything about the background because I'll spoil the moment. I'll just go straight to the acid MD treatment. So from what we have seen, it seems as if we've been bringing about all these problems about acid mine drainage. I would like to present to you a potential solution. So we have all these metals in AMD, and in chemical engineering setting, we have a process called neutralization, which is actually a very familiar grade 10 chemistry, acid-base reaction. But what's nice about this is we have learned in chemistry now that it's not only just acid-base reaction, but you also have precipitation happening. When you precipitate from hydromet, then you have a potential of then recovering your metal. That's where we can then find our value. It has been established in literature, therefore, that lime, which in this case we can refer to as a quick lime, which is calcium hydroxide, or hydrated lime in this case, which is calcium oxide and calcium hydroxide. You can see above all this is calcium carbonate. All these are sometimes mistakenly taken as lime. That's why I had to describe them on the side, as I would refer to them later. You might ask yourself, why lime? Well, lime is cost-effective, high reactive, and it's efficient. It's accessible in South African context, and it's relatively safe to handle. I'm afraid to say things like this. That's what I'm saying, relatively safe to handle. I wasn't supposed to put that there. Hopefully you will take it as I take it. I love this quote that says, engineering is the art of doing that well with $1, of which any bungler can do with 2 after affection. I would like to apologize in advance for this one. I don't mean it in a bad way. And I appreciate the work that all of us are doing as we are in the mineral to metal setting. So without further ado, I would like to take you through the process of lime. How do we get this lime then? If you can look at the picture far right, you have your limestone, which is usually heated to get your quicklime. And from the quicklime, then that's when you hydrate it to form a slake lime. So my project is about the slake lime dissolution in acid mine drainage. You might be thinking to yourself, if I'm saying this is a potential solution, and I'm counting all these good things, why am I doing this project then? Well, it has been established from literature again that there are complications with lime quality, which then will make us have impurities. And again, in our context, since we're looking at acid mine drainage with a lot of cocktail, although we're saying that these interesting value that we can find from acid mine drainage, but then it's hard to separate all these things, which then, okay, then my project then comes in this. Since acid mine drainage consists of elements such as sulfates, as you can see, you have more of the sulfates as I've highlighted, and iron, magnesium, as well as calcium, which is part of my reagent. Then the problem then is what I've shown with the pictures there. As you can see, when you react calcium hydroxide and your acid mine drainage, you end up forming gypsum, which then cover your particles that you want to dissolve so that you can release OH ion so that you can effectively neutralize your solution. I have listed the limitations there, but I'm willing also to give you a more detailed study on that, a more detailed conversation after this. The objective of this project is therefore just to determine the rate at which lime dissolution occur in the context of acid mine drainage neutralization under such condition using a shrinking sphere model. Then afterwards, we'll then determine the mechanism or reaction pathways between the hydrated lime and the species presented in acid mine drainage. These are my materials and methods. As you can see in the picture, I've been doing this for quite some time. We have established the experimental condition through to experimental set 1. So we are currently now dealing with set 2, which is the nature and type of an acid, as we are looking at acid mine drainage as an acid. Then my third part will be looking at the effect of the species present in acid mine drainage. This is just the preliminary results, as I have said it before. Then with that, I would just like to acknowledge CPU, Joint Barring Scholarship, and Hydromet, as well as my supervisors on the right. Thank you very much.
Thank you very much, Senzo.